Satellites are among the most important and least visible technologies in modern life. They support communications, navigation, weather forecasting, scientific research, and national security. In this video, we explore two of the best free websites for tracking satellites in real time and understanding the infrastructure orbiting above our planet. SatelliteTracker3D. SatelliteTracker3D is one of the most impressive public tools for visualizing satellites in orbit. At first glance, it appears to be a highly detailed 3D model of Earth. But behind this interface is a powerful educational platform that transforms orbital mechanics into something intuitive and visually accessible. Thousands of active satellites currently orbit Earth. Each one follows a carefully calculated trajectory determined by physics, velocity, altitude, and gravitational forces. Although these objects move at extraordinary speeds, their motion is highly predictable. That predictability is what makes satellite tracking possible. Most public tracking platforms rely on two line element sets, commonly known as TLEs. These are standardized orbital data files that describe the position and motion of an object in space. Organizations such as the U.S. Space Force publish orbital data that can be used to estimate where satellites will be at any given time. The website processes this information and converts it into a live 3D visualization. This allows us to observe not only where satellites are, but also how they move relative to Earth. One of the first things that becomes clear is that not all satellites occupy the same type of orbit. Different missions require different orbital configurations. Low Earth orbit, or LEO, extends from roughly 160 to 2,000 kilometers above the surface. This region contains Earth observation satellites, the International Space Station, and large constellations such as SpaceX Starlink. Because these satellites are relatively close to Earth, they move quickly and complete an orbit in roughly 90 minutes. Medium Earth orbit, or MEO, is home to navigation systems such as GPS, Galileo, and GLONASS. These satellites provide positioning and timing services that support transportation, finance, telecommunications, and countless other systems. Geostationary orbit, located approximately 35,786 kilometers above Earth, is particularly important. A satellite placed there appears fixed over the same point on the equator. This makes it ideal for telecommunications, broadcasting, and weather monitoring. Many of the satellites that provide television signals and meteorological imagery operate in this orbit. SatelliteTracker3D makes these orbital layers easy to visualize. When viewed in motion, the architecture of space infrastructure becomes remarkably clear. Low Earth orbit appears crowded and dynamic. Geostationary orbit forms a distinct ring around the planet. And polar orbiting satellites repeatedly pass over high latitudes to scan the entire Earth. One of the most interesting insights is how dependent modern civilization is on these systems. Satellite navigation supports aviation, shipping, agriculture, and smartphone apps. Weather satellites monitor storms and climate patterns. Communication satellites connect remote areas. Earth observation satellites track deforestation, wildfires, sea ice, and crop health. Scientific satellites study the Sun, Earth's atmosphere, and the broader universe. Many services we use every day rely on space infrastructure that most people rarely think about. Satellite tracking also reveals the scale of the new space economy. Commercial companies, national agencies, universities, and defense organizations are deploying satellites at an unprecedented rate. The rapid expansion of large constellations has transformed low Earth orbit into an increasingly congested environment. This growth has created new challenges. Space debris is one of the most significant. Defunct satellites, spent rocket stages, and fragments from past collisions remain in orbit. Even a very small object can cause severe damage because orbital velocities are extremely high. Collision avoidance and space traffic management are becoming increasingly important. Another useful concept is the distinction between active satellites and inactive objects. Not everything shown in tracking databases is operational. Some objects are no longer functioning but remain in orbit for years or even decades. Analysts often study both categories to better understand the long-term sustainability of space operations. SatelliteTracker3D also demonstrates how transparent space activity has become. Using publicly available orbital data, anyone can observe the structure of the near-Earth environment. This accessibility makes satellite tracking an excellent example of open-source intelligence. Public data, when organized effectively, can provide meaningful insight into advanced technologies and strategic infrastructure. Ultimately, this platform turns abstract orbital data into a clear and engaging view of the space systems that support modern life. Once you understand what you are seeing, the sky becomes far more than empty space. It becomes a dynamic network of technology continuously operating above us. Satellite Map. Satellite Map provides a different but equally valuable perspective on global satellite activity. Its interface is clean and intuitive, making it easy to explore large constellations and individual spacecraft. One of the most striking aspects of modern space operations is scale. Thousands of satellites are active today, and the number continues to increase rapidly. Large constellations are designed to provide global internet coverage, remote sensing, and communications services. Starlink is the most prominent example, but many other systems are expanding as well. This shift represents a fundamental change in how space is used. Instead of a small number of large satellites, operators increasingly deploy fleets of smaller spacecraft working together as coordinated networks. This architecture improves redundancy, scalability, and global coverage. Satellite Map makes this trend immediately visible. Another fascinating concept is revisit time. Earth observation satellites do not continuously observe the same location. They pass overhead at specific intervals. By combining many satellites into a constellation, operators can dramatically reduce the time between observations. This is essential for weather monitoring, disaster response, agriculture, and environmental analysis. The website also highlights how orbital design reflects mission requirements. Sun-synchronous satellites maintain consistent lighting conditions for imaging. Geostationary satellites provide constant regional coverage. Low Earth orbit constellations optimize latency and communications performance. Every orbit is a strategic engineering decision. Satellite tracking also has geopolitical significance. Space infrastructure supports both civilian and military functions. Navigation, reconnaissance, communications, and early warning systems are central to national capabilities. Understanding what is in orbit offers valuable insight into technological priorities and strategic investments. Another important point is that space systems are deeply integrated into everyday life. Financial networks rely on precise timing signals. Emergency responders use satellite communications. Meteorologists depend on space-based observations. Transportation systems use satellite navigation continuously. Many essential services would be severely affected without these assets. Ultimately, the value of tools like Satellite Map lies in their ability to make invisible infrastructure visible. They allow anyone to explore the spacecraft that orbit Earth and to better understand the technologies that support communication, science, security, and global connectivity. And once you see how much of modern life depends on satellites, you gain a new appreciation for the extraordinary systems operating silently above our planet.